Hello and welcome to part 2 of my free CCNA Cisco Certified Network Associate course. This course is free and will help you in clearing the certification exam. In the last video, we learned what is a computer network and we learned about various network devices. In today's video, we will look into interfaces and cables used to physically connect our network devices with one another, so that our devices are able to communicate with one another, hence making our network work. So without any more delay, let's get started. Look at this photo. This is a Cisco Catalyst 2960X series switch. In the last video, we understood that a switch is a device which has high concentration of ports, so the devices like clients and servers in same physical location can form a network to communicate with each other. This switch has 48 electric RJ45 ports and 4 SFP small form pluggable ports. Don't worry if you do not understand what is an electric RJ45 port or what is a modular SFP port. By the end of this video, you will be familiar with these. Don't worry if you do not understand what is an electric RJ45 port or what is a modular SFP port. By the end of this video, you will be familiar with what these are and more terminologies and standards, and you will be able to make your physical layer of the network. Let's look at these ports more closely now. On the left, you see an RJ45 port which uses copper based Ethernet cable, and on the right, you see an SFP port which is a modular port in which you can plug either an electric Ethernet based port or an optical Ethernet based port. But wait, what is Ethernet? And why are some ports fixed while others modular? And why are some electric while others optical? Let's answer each of these questions one by one. First, Ethernet. Ethernet is a way of connecting computers together in a local area network or LAN. It refers to a collection of standards. These standards define how to send data over a particular cable and at a particular speed. Also, these standards define rules that a node must follow to be part of that local area network. All the Ethernet standards start with 802.3 number prefixed with IEEE, which stands for Institute of Electricals and Electronics Engineers. From our first lesson, What is a Network, we had a definition from Wiki, and there was a part where communication protocols was highlighted and underlined. We see a similar term like standards, rules, etc. in this lesson also. So what does this mean? In simple terms, if two people want to communicate with one another, then they need to use a language that they both can understand. If one understands only English and the other understands only French, then they both cannot communicate. Similarly, Ethernet is a family of standards. As long as both the end devices communicate on same Ethernet standards, they both will be able to communicate with one another. These Ethernet standards differ on what kind of cable is being used, whether it is a copper or an optical cable, the speed at which both the devices will send data. This differs from 10 Mbps to 400 Gbps. Here Mbps stands for megabits per second and Gbps stands for gigabits per second. Don't get confused with bits and bytes. Remember, one byte is 8 bits and speed in computer network is always measured in bits per second. Lastly, these standards differ on the type and the length of the cable. First, let's look at the copper-based electrical Ethernet standards. In the first column, you'll see cables with speeds of 10 Mbps, 100 Mbps, 1000 Mbps or 1 Gbps and 10 Gbps. The second column is the most common name and is generally the name with which the standards are discussed and talked about in a conversation. The next two columns are IEEE names used in technical documentation such as data sheets, etc., which as a network engineer you will come across a lot. Note that the base here refers to the baseband signaling and the T refers to the twisted pairs. The last column is the maximum length of the cable as defined in standards for performance and technical reasons. That's a lot of information, and for your exam this is fair game, so you need to memorize this. As the informal IEEE standard name suggests, each of the standards are ending with T, which is twisted pair. What is this twisted pair? Let's have a look at it. One of the most common cables used in networking is UTP cable, which is an unshielded twisted pair cable. This is what a UTP cable looks like. There are 4 pairs of twisted cables. Each of the pair have different number of twists on them. The twists help in cancelling out electromagnetic interfaces from outside and wires of the same cable, also known as crosstalk. An RJ45 connector has 8 pins into which 8 wires can be inserted. But not all of the pins are used for all the Ethernet standards. For example, 10 base T and 100 base T, also known as Ethernet and fast Ethernet, use only 2 pairs, that is 4 cables or 4 pins. And 1000 base T and 10G base T, also known as Gigabit Ethernet and 10 Gigabit Ethernet, use all 4 pairs of cables. For 10 base T and 100 base T, we will need only 4 pins or 2 pairs of cables. On left, one pair or twisted pair on pin number 1 and 2 is used for transmission, connecting to right hand side pin number 1 and 2. And pin number 3 and 6 on the left hand side receives data transmitted by right side by pin 3 and 6. This allows transmission and receiving of data operations to happen at the same time, making the connection a full duplex transmission. This kind of one-to-one connecting cable is known as a straight cable. A straight through cable like this is used to connect a PC with a switch. Like PCs, routers, servers, etc. transmit on pin 1 and 2 and receive on pin 3 and 6. Therefore, if we were to connect these devices with one another using a straight cable, no communication will take place. For connecting such devices with each other, we need a cable which connects 1 and 2 pin on one device to 3 and 6 pin on the other side, so that the data transmitted using pin 1 and 2 is received by the other side on pin 3 and 6. Such cable is called a crossover cable. Unlike PCs, routers, servers, etc., devices like switches and hubs receive on pin 1 and 2 and transmit on pin 3 and 6. Therefore, to connect a hub or a switch with one another, like a hub to a switch and a switch to a switch, will also require a crossover cable. This table shows which device uses which pin pair to transmit data. Devices on the left, PCs, routers, wireless, access points, transmit on pin 1 and 2, and switches and hubs transmit on pin 3 and 6. In modern switches, a wrong cable, that is, a straight cable used to connect to another switch, will result in a connection between both. This is because when wrong cable is plugged in, the switches automatically changes the logic to make the link work. This feature of switches is called auto MDIX, where switches change the logic of transmission from 3 and 6 pins to pin number 1 and 2. Let's turn our attention now to higher speed copper Ethernet cables. We learned that Gigabit Ethernet and 10 Gigabit Ethernet use all 8 wires. Pairs 1, 2 and 3, 6 are used as explained earlier. The other 2 pairs are used in pins 4, 5 and 7, 8. Unlike in Ethernet and fast Ethernet cabling, in high-speed Ethernet cabling, there are no dedicated pairs for transmission and receiving, but each and every pair is bidirectional. This is part of the reason why they can operate at such high speeds. So now we understand about copper cabling. Let's switch our attention to a newer, a better technology of interconnecting our devices, fiber optic. Copper cables have restrictions of distances of 100 meters, whereas fiber have capabilities of reaching much greater distances. In the beginning of this video, we saw SFP slots can be used for both electric and fiber optic cables. We will now concentrate on fiber optic cabling. Rather than an electric signal over copper, these cables send light using glass as medium of transmission. Unlike a copper cable, which uses separate pairs of wire within the same cable to transmit and receive data, the fiber optic cable use separate cables to transmit and receive data. Both cables combined form same complete connection. Let's examine the structure of the cable. Take a look at this picture. There are four numbered parts from center to outer layer. Number 1 is the fiberglass core. Light passes through the core from one device to another, in turn transferring data. Number 2 is cladding that reflects light. Number 3 is buffer which protects the fiberglass from breaking. Number 4 is the outer jacket which protects the cable from external elements like rain, heat, etc. There are two main types of fiber optic cables. First is a multimode fiber cable, which allows multiple angles of light wave to enter the core. Second is a single mode fiber cable, which has a smaller diameter core, around 1/5 the diameter of common multimode cable. A laser-based transmitter sends light at a single angle, hence the name single mode. Both these cables have different roles in network. Multimode are less expensive as compared to single mode cables, as they use cheaper LED based transmitter compared to a single mode which uses a laser based transmitter. Multimode can reach to a lesser distance, but both can transmit data to a much greater distance as compared to a copper Ethernet cable. Let's look at some standards for fiber optic cables. The first standard is for 1 gigabit Ethernet, defined by IEEE 802.3Z standard. Works both on multimode and single mode, but as you can see, the maximum lengths vary for both the cables, up to 550 meters for multimode fiber and 5 kilometers for single mode fiber. The next three are all for 10 gigabit Ethernet, each of them defined under IEEE 802.3 AE standard, but they differ on type of fiber and the distances to which the cable can go up to. Again, I understand this is too much information to memorize, but for exam, this is all a fair game. Let's review what we learned in today's video by comparing UTP with both types of fiber optic cables. There is a trade-off between cost of cabling solution, distance and performance. Cost of UTP cable is low, but they are susceptible to interference and can be for distances up to 100 meters only. Whereas fiber optic cabling solutions are costly compared to UTP, with single mode being the most expensive cabling solution. Fiber optic cables are not affected by electromagnetic interferences as they are based out of glass medium and not copper like UTP. Fiber optic cabling are expensive but come with the benefit of distance at which the media can work. Multimode can work up to 500 meters and single mode can work up to 40 kilometers. Each cable has its own pros and cons, and one needs to weigh them in the context of the solution that the specific network needs. Time for some trivia. Which of the following Ethernet standard is a standard for gigabit Ethernet over a UTP cable? Option A 1000 base LX, Option B 1000 base UTP, Option C 1000 base T, and Option D 1G base T. You can pause the video here to test yourself. Okay, the correct option is option C. Let's review the incorrect option. Option A is a standard for gigabit Ethernet, but it's for fiber optic cable and not for UTP. Therefore, this is a wrong option. Option B and D are no defined standards. They are placed there to confuse us. So therefore, there are wrong options. Let's review another question. For each of the following options, select whether a straight cable or a crossover cable will be used. Consider auto MDIX feature is not available on any of the devices and we are connecting devices on a 100 base T network. Option A, PC and router. Option B, PC and server. Option C, PC and switch. Option D, switch and switch. You can pause the video here to answer the question. Okay, so we need to choose whether the combination will use a straight cable or a crossover cable. Let's answer one by one for each of the options. A. Since both the devices transmit on pin 1 and 2, the correct choice will be a crossover cable. B. Same as A, will need a crossover cable. Option C. A PC transmits on pin 1 and 2, whereas switch receives on pins 1 and 2. Therefore, a straight cable will be needed. Part D. Switch receives on pin 1 and 2. Since both sides are switch, question explicitly states that auto MDIX feature is not available. The switches will not be able to communicate with the straight cable. Therefore, a crossover cable will be needed. So in this question, you see that there are explicit instructions and you need to follow them while making a decision. Sometimes in haste, minute details are overlooked. Let me assure you that you will get ample time during the exam, so don't rush. Let's review one more question. You are a network administrator and want to place an order with a contractor for connecting to buildings in your organization campus. The buildings are 250 meters apart, but the cable ducts that are running beneath the ground are of 1000 meters. Which of the following Ethernet connectivity order will you place? Option A, fiber optic long mode. Option B, fiber optic short mode. Option C, long range UTP. Option D, fiber optic multi-mode. Option E, fiber optic single mode. You can pause the video here to answer the question. Okay, the correct option is option E. The question states that the buildings are 250 meters apart. Had the information stopped here, the correct option would have been option D. But it goes on to say that the ducts in the ground in which the cable is going to be laid are 1000 meters in length, which exceeds the maximum length supported by multi-mode cable. Therefore, correct option will be single mode cables, not option D. Option A, B and C are there just to confuse us. In real world, these are non-existent. Thank you for watching. If you want to leave a feedback or a comment, please leave it below. In case you have a question, you can also comment it beneath the video. I will try to respond to everyone as soon as possible. Do subscribe to the channel to get updates. Until next time, stay safe. Bye.